Hello everyone, today let's solve the problem Dima and bad XOR. So this was asked in Codeforces round 553 division 2. So I can just go through the question. I'll just summarize the question so that it will be easier for us to solve the problem. So what the question states here, we are given n into m matrix of non-negative integers, right? So here, just give me a second. We are given n into m matrix of non-negative integers. So they have strictly mentioned that it consists of the non-negative integers here. So we have to select exactly one element from each row. We have to select exactly one element from each row such that XOR of the selected elements is strictly greater than 0. They have strictly mentioned this one. This is very important point, right? So we have to select one element from each row such that XOR of the selected elements is strictly greater than 0, right? So if it is possible, whatever the criteria they have given or they have mentioned, if it is possible, then we have to output tag, right? And the selected column indices is 1 based. Here it is not 0 based or 0 indexing. So here it is 1 based indexing. Just keep this in mind, right? And the selected column indices is 1 based. They have strictly mentioned here it is 1 based. If it is not possible, means if XOR is always 0, then we have to output nie, N-I-E, N-I-E, nie, right? So this is the question. So again, I'm just gonna read out this one loud. Just listen to this. So we have given an n into m matrix. This one I'm speaking of n into m matrix of non-negative integers. We have to select exactly one element from the each row such that the XOR of the selected elements is strictly greater than 0. This one I'm speaking of, right? So that the such that the XOR of the selected elements is strictly greater than 0. If possible, if it is possible, if all the criteria satisfy basically, then we have to output tag, and the selected column indices is strictly 1 based. It is not 0 based here, it is 1 based. And if it is not possible, means if XOR is always 0, then we have to output NIE, NIE, right? If it is possible, then we have to output tag. If it is not possible, then we have to output NIE, nie, right? So these two uh, criteria we have to keep in mind. These two conditions basically we have to keep in mind, right? So I hope this part is completely clear. Question part is completely clear. Let let's discuss the input output part. So here we have been given 3 to uh, 0 0 0 0 0 0 thrice, right? So here the output that we need to get here is NIE, because here it is not possible. Means XOR is always 0 here in this case. So we have got the output NIE. For the second input, we have been given 2 3 triple 7 double 7 10 here. This one I'm speaking of. So here the output that we need to get here is tag along with 1 3 because here it is possible, right? So means in simple terms, one element from each row we have considered such that XOR of the selected elements is strictly greater than 0 here, right? So it is possible here. In this case, we have to return tag, tag along with the elements, right? Here 1 3 we have written this one, and they have strictly mentioned that the selected column indices should be 1 based, not the 0 indexed or it should be 1 indexed or the 1 based indexing, right? So just keep this in mind. So we are just done with the question part. I hope the question is completely clear. Let's quickly discuss the this one approach followed by the complexities, and then let's write the code. Initially, let's discuss the approach first. So here I have considered the same first example that they have given in the question. First example, we have 3 2 uh, double zero double zero double zero in individual lines, right? So the output that we need to get here is nie. So first thing I want to tell you here is we will be going with a greedy with bitwise XOR. We'll be going with a greedy with bitwise XOR or greedy with bit manipulation approach, right? Greedy with bit manipulation approach. Just keep this in mind. We'll be going with a greedy with bitwise XOR or bitwise manipulation approach, right? So let's move on with the step-by-step execution here. So initially what we'll do, we'll choose the first element in the each row. We will choose the first element in each row. Means we have all the zeros here. We have all zeros here. Uh, Accordingly with the approach, initially we have to choose the first element in each row. First element in each row means this one 0, this one 0, this one 0. So these three. Here also we have 0. Here also we have 0. Here also we have 0, right? So initially we'll choose the first element in the each row, all zeros, right? So 0 XOR 0 XOR 0. We are performing the XOR operation here. We know the truth table of XOR. Either, so suppose this one, let's consider AB here. So we have 0 0 0 1 1 0 1 1. So if either of the A or B is 1, then only the output will be 1, else it will be 0 0 0 will be 0 0 1 will be 1 because we have B1, and 1 0 will be 1 because A is 1, and 1 1 will be 0 because it should be either A has to be 1 or B has to be 1. If both A and B are ones, then we should, then the output will be 0 basically, or then output we should get is 0, right? So here in this case, since XOR is 0, we have to try to change one row's selection. Since XOR is 0 here, we need to try to change one row selection to different column to make the XOR non-zero, to make the XOR non-zero. Let's try to do that, right? In the next step, here all the elements are 0 man, because we have strictly given here 3 2 0 0 0 0 0 0. So this is the input basically, right? So we don't have any different value here. Here all the elements are 0 and we don't have any different value. So there is no way that we can make XOR, or that we can make XOR greater than 0, that we can make XOR greater than 0. There is no way to make XOR greater than 0. So what we will do, we will output NIE, NIE. So we will output NIE, NIE. If it is not possible, we have to output NIE, NIE. If it is possible, then we have to display the number along with the keyword TAK tag, right? So here it is not possible, right? It is not possible. So we will output NIE. So the output that we got here is NIE, which is equivalent to the output that they have given for the example 1 within the question. Example 1 within the question. So our approach works absolutely correct in this case. Our approach works absolutely correct in this case, right? So I insist you to try out with the same approach. You can go with the same approach for the second example as well. Instead of NIE, you will get the output TAK along with the numbers, right? Along with the numbers 1 and 3. So I can just check out for the example 2. I insist you to try out because you'll understand the problem better, right? So your way of solving the problem may be different and may be good, may be better than me, basically, right? So I insist you to try out for the example 2 in the same way, right? So now, as we are completely familiar with the approach, let's discuss the complexities part, right? So here, what is the time complexity? The time complexity is big of m into n. So why it is big of m into n here? One second. Yeah, here, because we will be traversing each element once. We will be traversing each element once, means in the worst case, we have to check the distinct values, right? So we have to check for all the distinct values in the worst case. So we will be traversing each element exactly once. So overall time complexity would be big of m into n. Basically we can write in this way, rather than big of m into n, we can go with big of n into m, n into m, right? So what would be the space complexity? Space complexity is big of n into m as well. Why it is big of n into m? Because we will be storing the matrix. We have to store the matrix somewhere, right? So we will be storing the matrix plus big of n for the result array. So we'll be making use of the result array. So overall, this one, overall space complexity would lead to big of n into m. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n into m respectively, right? So now, as we are completely familiar with the complexities and the approach part, it is better. So we are good to write the code. Let's start writing the code. So now let's start writing the code. I'll just come to compiler here. So we'll be making use of the different utility packages. I'll just go with, or I'll import the utility package here. So I'll just go with java.util.star. So this is fine. So next, let me go with the class name main here. Let me go with the class name main. So when I say main class, you can just make use of any name man for the class, right? So you can just give the question name itself or any relevant name for this particular problem, right? So here I'll just go with main, public static void main. So we don't have to use this one input output exception, I believe, uh, because we'll be making use of the scanner as well, and will not be making use of the out.println here in this case, or the print writer. So I'm will not be making use of the buffer reader or the print writer. We'll be going with the scanner for the input output. Just remember this one. I'll just go with sc equals new scanner. So this one will be system.in. So this is fine. We're just reading the input here, and we have to go with the number of rows and number of columns. As we are dealing with the grid, we have to go with the number of rows and columns, right? So I'll just go with n equals sc dot next int. The same thing. Let me copy this one. Uh, Same thing. Let's go with the columns as well. Instead of n, I'll just make this one m. Instead of n, I'll just go with the m, right? So this is fine. So next step is we will be going with the matrix to store the input. To store the input. So I'll just go with, this is 2D matrix, right? So I'll just go with a equals new int. A equals new int of n. Sorry. Just give me a second here. This will be n. This will be m. So this is fine. Let's go with the traversal part, or let's go with the iteration part. Sorry. So this will be int I equals 0, I less than n, I plus plus. So this is fine. Within the for loop, what we'll do, we'll go with one more for loop. So this will be int j equals 0. This will be j less than m. This is columns, right? So this is fine. Within the for loop, we have to fill the matrix. Means I'll just go with some random variable a of ij. This one, let me assign this one to scanner dot next int. Scanner dot next int. So this is fine. I hope this part is completely clear, man. Right, so I'll just come out of this one entirely. Let me come out of this one entirely. First, what I'll do, let me assign the result variable to new int. Means we have to store the selected column index. Nothing but we have discussed this one in the approach repeatedly. I have said we'll be going with a one based, not the zero based, right? So we have to store the selected column index. This is one based, not the zero based indexing per row. So I can just write in this way, int result equals new int of int of n. This is fine. So the next part is we will be going with the XOR of selected elements. Means I'll just go with uh, this one XOR sum. Let me initialize this one to 0. So the first step here, accordingly with the approach, the first step here would be we have to select the first column element from the each row. Again, I'm telling we have to select the first column element from the each row. Means I'll be going with the iteration part here, right? So this will be for int I equals 0, I less than n. Let me increment this one. This is fine. Within the for loop, I'll just go with iterated value of the result equals 1. Iterated value of the result is 1. Nothing but we are storing the one based index, or we are going with a one based index here, right? So this will be XOR sum. So we will be we have to go with the XOR, right? So I'll just go with the XOR. This one a of I, and this will be 0. This is fine. We are just performing the, or yeah, we are performing the XOR here, or we are calculating the XOR. We have to calculate XOR, so I have written this is nothing but the XOR symbol, right? This you have to know. We have solved so many problems on the bit manipulation already, right? So in the Node.js as well, in the JavaScript, in the Java as well, right? So we have solved n number of problems in the lead code and the Codeforces. So you have to know this one at any cost. So let me come out of this one. So next step after the previous step, the next step, if you remember, is if XOR is already non-zero, we are done. If XOR is already non-zero, then we are done. Means I can just write it in this way, or we can just articulate in the form of code in this way. This will be XOR sum not equal to 0. Then I'll just go with here, me go with tag. So I'll just go with tag here. This is fine. Tag here. So this is nothing but the valid configuration, man. So let me go with the for loop here. So this will be I equals 0, I less than n. So let me increment the I. This is 5. Within the for loop, we have to print the selections. We have to print the selections. So I'll just go with here. Print the selections means it would be iterated value of the result plus this one. What do we call? We have to leave the space, right? So I'll just go with a string and space within the strings, right? So we just have to print the selections. We are doing the same here, right? So I'll just come out of this one entirely again. So we have to, sorry, we don't have to print here anything. So let me do one thing. Else we don't have to print anything. I'll just leave this one blank, and we don't have to return anything as well else. So I'll just give return keyword here. We are not returning anything here, right? So this is fine, man. This is fine. So after this step, if you remember, we have to try changing one row selection to another column with a different value. So I'll be going with the nested loops here, two for loops here, right? So I'll just come here. This will be for int I equals 0, I less than n. So this one will be I plus plus. So within this for loop, this will be int j equals 0. Sorry, j has to be 1 actually. J less than m. So this one will be j plus plus. So within this for loop, first, if there is a different value, if there is a different value, then we have to change the selection. Then we have to change the selection. And if the solution is found, then we have to, what do we call? We have to print tag accordingly with the question. First, let's write the simple if condition. If there is a different value, means I'll just go with the if here. If a of, uh, if a of I and j, we have considered two for loops, we have written I and j we have made use of, right? So if it is not equal to, means if there is a different value, means if a of I 0 0, then we have to change the selection. And also we have to note down that this is one based index, not zero based index. I have stressed this one multiple times, right? I have stressed this one multiple times. This is one based index, not zero based index. So we have to change the selection here. I'll just go with the iterated value of the result. This is equal to j plus 1, j plus 1. And also let me go with println, nothing but we have to print tak, right? So we have to print tak if the solution is found. That's what we are doing here. So this is fine. The next step is we'll be going with one more for loop here, because we have to print the updated selections as well. We have to print the updated selections as well. So similar to this one, man, similar to this one. So what shall I do here? Let me copy the same thing and make the necessary changes. So 26 to 28. So I'll just copy this one, come here, let me paste it over here. Instead of I, I'll just give k. This will be k less than n, and instead of I, this will be k plus plus. We'll be incrementing the k. And what we need to print here, instead of iterated value of the result, this will be result of k plus same thing, right? So we need to leave space here as well. So we have to print the updated selections every time. So we are this one writing, we have written this one here, result of k plus this one, this line, right? I hope this part is completely clear, man, right? So next what we will do, again same thing, else we don't have to print anything and we don't have to return anything. So let me give same thing here, right? So this is fine, I think this is fine, I hope, right? So next we are left with only one thing, that is if all the rows have equal elements and XOR is 0, then if it is not possible, sorry, then it is not possible, right? If all the rows have equal elements and XOR is 0, and after performing we have if we have performed XOR and we have got 0 for all the things, then it is not possible. Then we have to print NIE. So in our case, we considered first example that was given in the question. All the rows had equal elements and XOR was 0. XOR was 0. So it was not possible. In that case, we displayed NIE, right? So that's what we'll be doing here. In this case, we have written everything. We just have to print here, I'll just go with println. So we just have to print NIE here, else we'll go with NIE. So this is it for the code. This is it for the code. So I have to keep this one. Let me cut this one here. So I have to give this one here. Right, sorry. Yeah, this is fine. Checking before checking the code with different inputs, I want to copy paste the this one signature starter template. Just give me a second here. So let me come here. Let me paste it over here. Just ignore this one. Let's concentrate on the logical part. I'll just go to the question. So let me copy the input. So the output that we need to get here is NIE. Let's check whether this works or not, man. So we have error here. I have not mentioned int here. I have to mention int. Line number 52, man. So here, let me mention int. This is fine. Let me run this one again. So yeah, now we are getting the output NIE, right? So that was the problem. I had not mentioned int here, right? So I hope this part is completely clear, man. So now let me copy this one, and the output that we need to get here is TAK tag along with in the next line along with the numbers or the integers 1 and 3, right? So let me copy the input here. Let me paste the input here. Yeah, output that we are getting here is 1 tag 1 3. So here this has to be present on the same line. So this doesn't matter, I think. I don't know. I hope this doesn't matter, man. Let me copy the same thing. This is working correctly, but this has to be uh, 3 has to be present next to 1 in the same line, right? After a space, it has to be present like this. I have to give this one here, leave the space, but I have left the space right here. Is it this? Don't know. I hope this doesn't matter. If it gives error, then we can change the code, right? So let me come here. Let me select. So this is problem B, right? So this is showing problem B. Just select problem B and let me paste it over here. Let me hit the submit button. I hope this works for all the test cases, man. Let's see. Somewhere I have missed something, I think. Or if it works, that's completely fine. Let's not touch the code again. So yeah, you can clearly see here running on test 3. Let's not touch the code again, man. So that's the mantra, right? So if the code works, then we shouldn't touch it. So let's wait for some time. Yeah, you can clearly see here in the toast it is showing accepted, right? So the verdict that we got here is accepted. So whatever the code that we have written works absolutely correct for all the test cases, right? I hope the solution part is completely clear along with the approach and the complexities. We went with the greedy approach along with the bit manipulation or bitwise XOR, right? For now, this is it. Thanks for watching, guys.